Hello everyone, we are Team ThinkBots and our idea is Coastal Sentinel, a real-time citizen and social media ocean hazard platform. This project is part of Smart India Hackathon 2025 under the disaster management theme. The problem statement ID is 25039, the category is software and our team ID is 69681. So, our idea directly addresses the problem statement of developing an integrated platform for crowdsourced ocean hazard reporting and social media analytics. So, our aim is to empower citizens, coastal residents, volunteers, and authorities to collaborate in real time for safer and more resilient coastal communities. So, let me walk you through how our idea works. India's vast coastal line is often exposed to hazards like sudden flooding, erosion, and dangerous debris. During such events, authorities cannot always be present on site immediately. So, this leads to delays in response and put lives, property, and livelihoods at risk. So, our proposed solution is to build a unified web and mobile platform where citizens and volunteers can directly report hazardous events by uploading geotagged photos, videos, or text. So, the unique aspect of this solution is that it combines crowdsourced citizen reports with AI driven social media listening. Using natural language processing and multilingual support, we can track real time trends across platforms. So, the application authenticates each user, ensuring reliable data. Once reports are validated, they are instantly available to disaster managers and coastal authorities. This makes timely action possible even when officials are not physically present at the site. In short, it bridges the gap between citizens and authorities. What makes Coastal Sentinel innovative and unique is the way it integrates multiple data sources. First, we are combining official INCOIS forecasts with user generated hazard reports and AI based social media insights. This creates a much richer and more accurate picture of the situation. Second, we are focusing on multilingual accessibility. Since Indian coastal communities speak diverse languages, we are using multilingual models to make the platform inclusive and usable for all. So, together, these innovations ensure that both citizens and authorities get validated real time hazard updates, leading to faster response and improved safety. Now, let's look at the technical side of our solution. For the mobile application, we use Flutter, which allows us to build cross platform apps that work smoothly on both Android and iOS. So, citizens can quickly upload hazard details even from basic smartphones. For the dashboard used by the authorities, we use React with Mapbox. Makes the dashboard interactive, while Mapbox lets us display hazards directly on the maps with precise geotagging. The backend is powered by Node.js. It is lightweight and efficient for handling large number of user requests. To support instant updates, we use WebSockets, which means the moment a hazard is reported, it appears on the official's dashboard without any delay. All reports are stored in PostgreSQL. For location based queries and mapping, we use PostGIS, which adds spatial data handling. This makes it possible to run queries like show hazards within a certain distance of a coast. So, when it comes to analyzing images and videos, we use deep learning models such as YOLO V8 and CNNs like ResNet or MobileNet. These models help identify events like flooding, erosion, or debris from the uploaded media. For continuous data flow, we integrate Kafka, which manages real time streaming of inputs. To handle background tasks like image analysis without slowing the system, we use Celery. And finally, for multilingual text reports, we use mBERT, which is trained on Indian languages. So this ensures reports submitted in Hindi, Tamil, Telugu, or other regional languages are processed accurately. Each technology in this stack plays a specific role, ensuring the system is scalable, fast, and inclusive. With that, I'll pass it on to our teammate to explain the next part.
Yeah, I'll explain the workflow of our project. A user first registers on the platform. They upload hazard information in the form of abnormal images, videos, or text. The system automatically geotags this media. The data is analyzed using YOLO V8, CNNs, and Kafka pipelines. Finally, validated alerts or reach both citizens and authorities instantly, enabling quick response. This streamlined process ensures that the right information is available to the right person at the right time. When it comes to feasibility, our solution is both technically and operationally viable. Technically, we are building on reliable open source technologies like PostGIS for spatial data and Mapbox for mapping. Operationally, India's coastal population is increasingly mobile savvy, and with our multilingual interface, inclusivity is guaranteed. The UI is sampled for everyday users, while dashboards are designed for quick decision making by officials. We have also thought about challenges. For limited connectivity, we plan to use offline queues with later sync. For API limits and privacy concerns, we use platform partnerships and paid tiers. And for multilingual model accuracy, we will apply up incremental training with regional datasets. This ensures smooth operation even in challenging conditions. The, pot- the potential impact of a coastal sentinel is wide-ranging. Socially, it enables foster and validated early warnings, which can directly save lives and property. Economically, it helps reduce damage, costs, supports fisheries, and ensures continuity for tourism industries. Environmentally, the system builds a long-term data set that is valuable for climate and coastal studies. And most importantly, it empowers communities. Citizens are not just passive observers but active contributors and first responders in times of crisis. This combination of social, economic, environmental, and community impact makes our solution sustainable and future ready. And that's exactly why we believe Coastal Sentinel can make a real difference. Finally, our idea is strongly backed by research. We referred to studies on the contribution of social media analytics to disaster response, crowdsourcing geospatial data for monitoring, and how volunteered geographic information can enhance enhance marine environment monitoring. One such example is the analysis of natural hazard impacts in Australia using social media data. These works guided us in shaping Coastal Sentinel to be both practical and research driven. With this, I conclude our presentation. Thank you.